So the next topic we talk about is the benchmark risk minimization for life insurance policies. So pricing of standard life insurance has been conducted traditionally under the risk neutral pricing framework, and we want to extend that to be under the benchmark approach. Since the life insurance policies depend on risk factors such as mortality, which is unhedgeable, we cannot guarantee the complete hedge of life insurance policies. So for this purpose, we resort to benchmark risk minimization, which minimizes the benchmark hedging error under the real-world pricing probability measure. And the benchmarked risk minimization portfolio has a minimal cost for hedging, for achieving such a risk minimization. So first we look at the financial market model where we have a insurance claim H, which is priced under this real-world pricing formula, given its current value as VH. We consider under the benchmark approach the pricing of a bond, zero coupon bond, which is the primary hedging instrument for standard life insurance policies, which do not depend on market risk factors, but only depend on mortality risk factors. So a zero coupon bond price and benchmark approach is given by the second equation. And the benchmark, the zero coupon bond price, satisfies a driftless SDE, where the delta hedging strategy is given by the derivative with respect to the GP price. So those are the tools on the financial market side that are used to price these standard insurance policies. So the mortality model is such that we have a deterministic mortality model where the surviving probability from time to t to time u is given by this exponential of the integral of the force of mortality process. So we consider a portfolio consists of a number of L lives. So the N is the number of alive policyholders at time t, which is a sum of the indicator that the lifetime NT is the number of death. So it's a sum of the indicator of I's life. So if Ti is less than or equal to T, which means I's policyholder has died. So the sum of the death is NT. And NT is a compound Poisson process. NT is a Poisson process, inhomogeneous Poisson process, which can be where the trend can be subtracted to obtain a martingale MT. So the benchmark risk minimization is such that a hedging strategy for a contingent claim HT is given by the sum of the initial portfolio value plus the change from trade, gain from the trade, plus some error term. So the total value is given by the real-world pricing formula but this portfolio on average is not, this portfolio is not exactly self-financing, but it is mean self-financing in the sense that um, the first two terms is a self-financing strategy, and the error term is a zero initial value local martingale, orthogonal to the security processes S. And the benchmarked terminal payoff is given by its current value plus the hedging over the future period of time and the change in the error term. So this is a benchmark risk minimization strategy to hedge a not completely hedgeable terminal payoff HT. And in our case, for each individual policy holder, assuming that we are considering here a standard insurance, standard term insurance, endowment insurance, which says that if the policyholder dies within the insurance term, he will get paid immediately, unit amount of wealth. If he survives, he will get paid at the maturity. So this is a standard endowment insurance policy, and the value of this individual policy at the end of the policy period is given by this amount. If Ti is equal to T, this is equal to 1 at the expiration. And if Ti is less than T, then the policyholder will receive a payment of 1 at Ti. But for simplicity, we want to invest this 1 unit of wealth into the growth option portfolio and wait for it to expire at time T, so that the value of this policy at time T is equal to this ratio. And the portfolio value of the sum of all these individual policies would just be the sum over all these individual policies, and this can be given by the next equation, where the mortality process N obviously play a role. So this is a surviving part of the policyholder having this amount of value. And the first term referred to the payments made to the policy holders who died before maturity, and assuming that payment is invested in the growth option portfolio until maturity. So applying the real world pricing formula to this expression, we get the next equation, which calculates the value of the entire portfolio at arbitrary time T. Here, this RT. This is a total value, including both the paid part and unpaid part. So RT is given by the unpaid part. Is the average value of the unpaid portfolio, the portfolio that is still alive, still enforced, and it is given by the integral of all the future payments to the surviving policyholders dying over that period, plus all the survived policyholders, and they are going to receive zero coupon bonds either at maturity or at their their death moment. So, and this benchmark risk minimization strategy will invest a unit of delta number of shares in the growth of the portfolio after some calculation, which is given by the next equation. Next, we see some numerical examples. We first look at these mortality rates. We consider a deterministic mortality model where the force of mortality curve is drawn here based on empirical data. And we first simulate some samples where the thick curve is a realized GP, namely the S&P 500 index over 30 years, and the other curves, the other paths are simulated based on the estimated MMM parameters. And the number of mortalities, we also simulated an equal number of paths where we choose an arbitrary one as a realized one just for convenience. So here we show the results out of each investment, out of each realized scenario, the price processes. The first panel shows the price process of the portfolio, of the life insurance contract portfolio. And second one is the benchmark price process. As you can see clearly, the benchmark price process actually decreases over time. And the P&L process, which is a hedging error part, and eta part, and which after benchmarking it becomes essentially a constant. So here the P&L process being negative means that the portfolio of life insurance policies lose money over time, which means the insurance company makes a gain. So recall that these values are the values as seen by the policyholders. So this group of policyholders' portfolio values decrease with time. This shows that the portfolio process, as seen by the insurance company, is actually making a gain. So here's a result of the hedging. So since we have a unhedgeable risk factor, namely the mortality risk factor, we cannot guarantee to perfectly hedge the investment, the portfolio, so that the terminal value of the realized the terminal value of the portfolio under the scenarios will not have will have a variance. So assuming the unhedged portfolio to have a variance 1, the hedged portfolio, which is the difference between the benchmarked, difference between the BRM strategy value minus the hedging portfolio value has a much reduced variance of about 13%. And since the benchmark approach optimizes in the benchmarked domain, so in the benchmark the variance is less than 1%. So which means significant variance reduction is realized by following the benchmark risk minimizing strategies. So in summary, if the life insurance policies are priced or hedged under the benchmark risk minimization strategy, we see strong variance reductions on one hand, and on the other hand, the portfolio of life insurance contracts, as seen by the insurance company, actually realized a net gain. So this is not possible under risk neutral pricing framework, where since we working with discounted security price processes, which means the risk-free interest rate is zero, and the risk neutral framework, portfolio price processes should on average be a constant, but this is not the case. We saw on average a negative trend of the insurance policies values, which means a positive trend for the insurance company who sold the portfolio at the initial date and hedges and pays its liabilities over the period of the policy.